We're going to further explore the quadratic formula in this video. We're going to look at some special cases where when we solve for the roots or the solutions or x-intercepts on our parabola, sometimes we get the same answer twice, or maybe sometimes we don't get any real answers at all. So we say sometimes we have situations in which our parabola only intercepts the x-axis once, and we say that's got to be at its vertex. So for instance, if we were to have a situation like we're about to see here, it is very possible that when we say go solve this quadratic thing, it looks like, something like this. And what we're going to find is that it has an x value that caused our y value to be 0, but it's the same x value twice. So we call this a double root, okay? So what we want to do is we want to go solve this equation right here. Now I notice that this is quadratic, except for, excuse me, it's not set equal to 0. So what we're going to do first is we're going to set both sides equal to 0. That is, we're going to subtract 5x. We're going to add 9 to both sides, so minus 5x. Plus 9. I'm going to squeeze this in here. So when we rewrite this, what we get really is this. We'd say, well, I'd have x squared. A negative x and a negative 5x give me a negative 6x. And we say I also added 9 to both sides. So what we end up with is something like this right here. So we say, all right, well, let's go solve this. Now, I got to point this out. I really do. If anybody ever asks you to go solve something, the first thing we should do is check to see if we can factor it. And as a matter of fact, this is a trinomial where a is 1. So this would actually factor, and this factors down into x minus 3 equals 0. So if we were solving by factoring right now, we'd just go ahead and skip straight to the end. We get x minus 3 equals 0 or x minus 3 equals 0. Somebody here was 0, so I get x is 3 or I get x equals 3. Okay. So when we solve this, when we graph it at least, we're going to go find that this graph hits the x-axis at x equals 3. As a matter of fact, I'm going to go graph this right now. We say x squared minus 6x plus 9. Let's go take a look at what this looks like. So we say y equals x squared minus 6x plus 9. And so you can see on our graph here that it hits at 3, 0. And those are the solutions we're supposed to get. So we got a double root. We got the same answer twice. We would call this, let's go ahead and write a note here. This is called a double root or double 0 or a double x-intercept. Okay. All right, so that being said, here's a question I kind of want to wrestle with in this video, but is, could we have used the quadratic formula and come up with the same answer we did pretty easily with factoring? And the answer to this is yes. So we say in our quadratic thing, set equal to 0, in standard form we say 1 is our a value, b is negative 6, and c is 9. So you get 1, negative 6, and I get 9. So piecing together our quadratic formula, it would have said, well, your solutions have to be of this form. They have to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, where our b value is negative 6, so negative 6 and negative 6. We plug in our a value is 1, so we say 1 and 1, and our c value is 9. So carrying all this out, we say, well, I get two answers. I get negative 6, so positive 6, plus or minus the square root of something all over 2, where in this case, in this instance, we get negative 6 squared is a positive 36, a negative times a positive is a negative, and 4 times 1 times 9 is 36. So we actually dig out two answers here. We get 6 plus or minus the square root of 0 all over 2. And so this is why we get the same answer twice, because really when we list these separately, we get 6 plus the square root of 0 over 2, which is really 6 plus 0 over 2, or 3. And we get x equals 6 minus the square root of 0 over 2, or 6 minus 0 over 2, which is still 3. Okay. So this would be an instance where we get the same answer twice. How about if we were to solve a quadratic equation and it never hits the x-axis? So again, we're going to look at a situation now where maybe my parabola, it's doing this. Who knows? But the fact is it doesn't have any real x-intercepts. So what kind of answers are we going to produce with the quadratic formula? Well, let's go ahead and set this equal to 0 first. I'm going to bring this 2 back over. So we get this. We get negative x squared plus 2x minus 2 equals 0. And just because I like for this to be a positive in the front, let's take both sides. Times a negative 1. And just flip everybody's signs over here. Not that it's going to matter much, but we get this now. We say x squared minus 2x plus 2 equals 0 times negative 1, which is 0 still. So we get an a value of 1, a b value of negative 2, and a c value of 2. Now, in a normal instance, I would have checked to see if I could factor this first. So I'd say, well, it's a trinomial where a is 1. Could I perhaps think of two numbers that multiply out to be a positive 2 that add up to be a negative 2? And actually, none exist. So we would try maybe completing the square next, or using roots. Roots would fail because we have a squared term added to the first power term. And then maybe completing the square, but completing the square really is the quadratic formula. So let's go ahead and start with the graph of this. X squared minus 2x plus 2, just to get a look at what its x-intercepts look like. So x squared minus 2x plus 2. And you'll notice that this never hits the x-axis. So I can tell you that it does have to have two roots, but they are not going to be real numbers. They're not going to be on the x-axis. So let's go ahead and piece together our quadratic formula here. We've already recorded these important or imperative values here. We say, well, then our answers must be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, where now plugging these values in, we get a b value here of negative 2 and negative 2. We say an a value of 1 and a c value of 2. So in this case, when we simplify this, we get two answers here. We get negative 2, which is 2, plus or minus the square root of, and this is all over 2 times 1. But I get negative 2 squared is 4. A negative times a positive is a negative. And we say 4 times 1 times 2 is 8. So we can see here in this case, we actually get two answers. Let me not write x again. That's redundant. We can say we get two answers. We get 2 plus or minus the square root of negative 4. All over 2, which by the way can be simplified. We know that that's 2 plus or minus I times the square root of 4 all over 2. And as a matter of fact, we might as well just say this. This is 2 plus or minus 2 times I over 2 because the square root of 4 is 2. So now this can be simplified. I'll drag you this way, but we say dividing everything by 2, we get 2 over 2, which is 1, plus or minus 2 over 2i, which is 1i. So we got two answers on this one. We're going to make a little commentary on this one, but we say both non-real, or both complex, but we want to say and non-real. And the reason why we say non-real is because then we say it has no real x-intercepts. We must have a parabola that never hits the x-axis. Cheers.